Welcome to Space Repo. All right, get ready, because today we are diving headfirst into one of the most mind-bending and, honestly, one of the most terrifying concepts in the entire universe. We're talking about black hole time dilation. You've probably heard this absolutely chilling line from the movie Interstellar. But here's the thing. That wasn't just some Hollywood screenwriter's wild idea. That terrifying math, it's literally baked into the laws of our universe. So how in the world is that even possible? Well, to get it, you kind of have to be willing to break your brain a little. You have to toss out everything you think you know about how time and gravity are supposed to work. And it all goes back to one person in one idea that completely shattered our understanding of reality, Albert Einstein and his theory of general relativity. See, Einstein's incredible leap of genius was realizing that space and time, they aren't two different things. Nope. They are woven together into this single four-dimensional fabric he called space-time. So just forget the old idea of gravity as some invisible pull. Instead, picture a bowling ball on a trampoline. The ball doesn't pull a marble towards it. It creates a deep curve, a well in the fabric, and the marble just rolls down into it. That is gravity. And here is the absolute kicker. Since time is part of that fabric, when you warp space, you can't help but warp time right along with it. Time itself can be stretched and squeezed just like spandex. Okay, so now let's take this wild idea and crank it up to 11. Let's go to the most extreme gravitational environment we can possibly imagine, a black hole. A black hole is so unbelievably massive, so dense, that it doesn't just create a little dip in spacetime. It punches a bottomless hole through it, a point where the curvature is basically infinite. And that extreme warping is what causes this phenomenon called gravitational time dilation. It's a really simple idea at its core. The stronger the gravity, the deeper you are in that gravity well, the slower your clock ticks compared to someone far, far away. Let's run a quick thought experiment. Imagine your friend is just chilling out in deep space, far away from any major gravity. Their clock is ticking away normally, but you've decided to take your ship for a joyride, dangerously close to a supermassive black hole. So let's get into the terrifying first-person details of what this would actually feel like. You're in your ship, orbiting just outside the black hole's point of no return, the event horizon. Now this is the really bizarre part. For you, inside that ship, everything feels completely and totally normal. Your heart is beating once per second. Your watch is ticking along just fine. You feel like time is flowing perfectly. But then you look out the window. You decide to check in on things back home, to look back at Earth. And this is where the absolute horror of your situation kicks in. You glance at your watch. Okay, it's been 60 seconds, just 1 minute. In that single minute that passed for you, 84 years just flashed by on Earth. Generations were born, lived their entire lives, and died, all while you were just sipping your coffee. Okay, so let's say an hour goes by. You finish watching a movie. For you, it's just 1 hour. Back on Earth, 5,000 years have passed. Human civilization as you understood it is nothing but ancient history. You're not just a person anymore. You're a fossil from a long-forgotten past. Everyone you ever knew, everything you ever loved is gone. They're dust. You would literally be watching the entire future of the universe unfold at hyperspeed, trapped in your own little bubble of slow time. It's the ultimate solitary confinement. Now you might be thinking, okay, that's a cool sci-fi story, but this is just some crazy theory that only matters for black holes, right? Wrong. This effect is real, it's measurable, and it's happening all around us, right now. You know the GPS in your phone? The satellites that make it work are orbiting up where Earth's gravity is weaker. That means their clocks actually tick a tiny bit faster than ours down here on the surface. If engineers didn't constantly correct for this, your GPS would be off by miles every single day. Heck, your head technically ages faster than your feet. It's a proven law of physics. And what this all means is that for any future deep space explorer, the biggest enemy isn't the distance or the radiation. It's time itself. The fundamental laws of the universe say that any trip into a deep gravity well means you are sacrificing the past you left behind. Which leaves us with one last, really unsettling thought to chew on. If your time can run at a different speed than my time, does a single universal now even exist for everyone? The answer from physics is no. The idea that we're all sharing the same moment is just an illusion.
Thanks for joining us on this trip to the very edge of time. If you want to keep exploring the biggest, weirdest ideas in the cosmos, make sure you subscribe to Space Repo and hit that notification bell. We'll see you on the next one.